All right, this next video is structuring. This is one of the most important things that students need to know how to do. Structuring is knowing all of the combinations that lead up to 5, all of the combinations that lead up to 10, and all of the combinations that lead up to 20. By the end of first grade, they should know all of the combinations that lead up to 5 and 10. And that does not mean knowing all of the combinations to make 5 and to make 10. It means knowing all of the combinations that make 1, 2, 3, 4, and 5 to be able to successfully structure to 5. And then all of the combinations to make 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 in order to be able to successfully structure to 10 with materials and without materials. And by that, I mean they can do it with counters in front of them or with the math rack, and then they can do it without as well. So I'm going to show you what we do for that. This might get tricky to do with them following along in the video. This is kind of something that you need to do with your child to practice, just because, you know, I can ask, but I can't see their answers. I don't really know if they're showing what they should be showing. I can show the answers as well, but this is something you really should do one-on-one. So if you need to, while you're watching this video with your child, pause it when I ask a question, have them show you, and then they can check their answer with what I'm showing. So normally we start with dot patterns. These are for subitizing, so it's for making groups so that they know combinations to different numbers. So I'll show them a dot pattern like this, and they have to tell me, I see 3, and I'll ask, how did you see it? And they'll say, I saw 2 and I saw 1, and that helps them learn 2 plus 1 makes 3. So again, to do this with your child at home, you can either make your own dot pattern cards or show them my video, but pause it each time so that they can give you an answer, because with some of these dot patterns, there's more than one way to break it up. For example, this one is 6. They could see it as 4 and 2. They might see it as 3 and 3. They might see it as 5 and 1, and I will say all of those answers, but I want them to be able to check with somebody right then and there if they're correct or not. All right. How many dots do you see? And then I usually only hold it up for 2 or 3 seconds, and they have to tell me, okay, I saw 4, and how did you see that? Oh, I saw 3 and 1, or I saw 2 and 2, okay? How many dots? Good. 4. How'd you see it? 2 and 2, or 3 and 1. How many dots? Good. 4. How did you see it? Most of them with this one say 2 and 2 because it's very easy. 2 and 2, and this is a dice pattern. How many dots? 5. Good. How'd you see it? 3 and 2, or they can see it as 3 and 2. They can break it up however they want to. 4 and 1. How many dots? 6. Good. How'd you see it? Most kids break this one up into 3 and 3 because, again, this is a dot pattern if you turn it this way, so they're used to seeing it on a dice pattern, not a dot pattern, sorry. This one is tricky for them. They look at it and they automatically say 10 because they're used to seeing pyramids as groups of 10. I tell them my dot patterns do not go above 6. So if you're guessing 7, 8, 9, or 10, you're going to be incorrect because my dot patterns don't go above 6. They're not tested on dot patterns above 6. So a lot of them start to memorize this and know it's 6, which is okay. But 6. Okay. How many dots? 3. How did you see it? 2 and 1. Good. How many dots? 5. Good. How'd you see it? 3 and 2. I saw it as 4 and 1. And they don't have these in their hands. They don't actually have to show me 2 and 3 or 4 and 1. They just tell me with their words. I'm just showing in case the kids are watching and they want to see how to break it up because they're not sure. How many dots? 5. Good. How did you see it? 4 and 1 more. 2 or 3 and 2. How many dots? 3. How do you see it? 2 and 1. And how many dots? 4. Good. How'd you see it? And most kids will say 2 and 2 for that one as well. A lot of kids, when it comes to Groups of 4, they say 2 and 2 just because they all know that, they all know that 2 plus 2 makes 4 because of their double facts. The next part of structuring is finger patterns. So I have a card in front of me that tells me what finger patterns they need to show me. They usually need to show me 4 on their fingers, 3 on their fingers, 6 on their fingers, 9 on their fingers, 8 on their fingers, and then 5 on their fingers 2 different ways, and 7 on their fingers 2 different ways. When I do this in small group, because we do all of these skills in small group and whole group, I will ask one student to show me all of those things before I move on to the next one, because every single student in the class needs to be able to show all of those finger patterns. So this is the part where it's trickier to have them just go along with the video for it, because they need somebody telling them, okay, that's not 4, that's not 7. Oh, you already showed me that way, you need to show me a different way. So they can, of course, follow along, but it's easier if somebody's doing it along with them. So I'm going to ask them to show me a way to make one of those numbers, and then I'm going to wait, and then I'm going to show it a couple different ways on my screen as well. So show me 4 on your fingers. Okay, so they can show it as 4 and 0, 3 and 1, or 2 and 2. And it's really important that they're not going like this. Because if they have to count out 1, 2, they don't know the patterns or the combinations automatically, and they're going to get knocked down a level as well. And I tell them that every single day so they know that. Some kiddos still have to, so if they're still doing that, I remind them, you know, try not to do that. Think about the combination in your head before you try to put it on your fingers. But some kids just need to still, but most of them don't. Okay, show me 3 on your fingers. So they can show it as 3 and 0, or 2 and 1. Show me 6 on your fingers. You can show it as 5 and 1, 4 and 2, or 3 and 3. Show me 8 on your fingers. Okay, so they can show it as 5 and 3, or 4 and 4. Those are the only 2 ways on their hands that they can show 8. Show me 9 on your fingers. The only way to show 9 is 5 and 4. And what I like to do is I like to ask them, what 2 numbers are you showing me? So that they know they're showing me a 5 and a 4, and 5 plus 4 makes 9. Okay, the next 2 they have to show in more than one way. So show me 5 on your fingers. Most of them will show 5 and 0 first. Show me 5 a different way. 3 and 2 is another combination. And then 4 and 1 is another combination. They cannot show you 5 and 0, and then 5 and 0 again. That's the same way. They need to either show you 2 of those 3 ways that I just showed you. 5 and 0, 4 and 1, or 3 and 2. Okay, now show me 7 on your fingers. 5 and 2, okay. Show me 7 a different way. 4 and 3. Nice job. 7 is where they get stuck the most. The whole school, honestly. That's what our math coach keeps telling us. A lot of kids know this is 7. They don't necessarily know that it's 5 and 2, but they know this makes 7, because when somebody asks them to show them 7 fingers, they usually hold up this. They don't know that this is also 7. So what I tell them is, you have 5 and 2 up right now. Take 1 away from your 5. What do you have? 4. Now take that 1 and add it to your 2. What do you have? 3. Do you have 7 fingers up? And they either have to go 1, 2, 3, 4, 5, 6, 7, or they can go 4, 5, 6, 7 and count on to figure it out. But that is the trick I show them to count on. Okay, the last part of structuring is with the math rack. So that is this. There are 5 white beads and 5 red beads. I always tell them, no matter what, there's always 10 beads on the top. We don't work with the bottom yet. There's always 10 beads on the top. I cannot take them off. So even if there's beads hiding, they're still there. There's still 10. Okay, so what I do with this is I just ask them, or I show them different bead combinations, and I ask them how many more to make 10. For example, I might show them 5. And I usually try to cover the ones on the bottom. But I might show them, okay, there's 5 white beads. How many beads are missing? 5. They all know that 5 plus 5 makes 10. But when I show them this, I'll say, how many beads? They'll tell me 7. Okay, how many are missing? 3. What's the number sentence? 7 plus 3 makes 10. If you see that your kid or your child is struggling with this, I remind them, okay, how many white beads are always on a rack? They tell me 5. Okay, good. So you know there's 5 white beads. We don't need to count those. Count on with how many red beads there are. They go 5, 6, 7. Okay, you have 7 here. How many red beads are here? 2. How many red beads are there supposed to be? 5. So if you have 2, how many red beads are hiding under my hand? And they'll usually be able to tell me 3. So I'll say, okay, you have 7. How many are missing? 3. Okay, what goes with 7 to make 10? 3. So we really use the colors on the math rack to help them figure out the combinations to 10 if they don't know them automatically. So I'm going to do a few of those, and they can just follow along with this part. How many beads are there? 9. Good. How many are hiding? Yep, just 1. Good. So what's the number sentence? 9 plus 1 equals 10. Nice job. How many beads do I have? 6. Good. How many are hiding? 4. Good. What's the number sentence? 6 plus 4 more makes 10. Nice job. Okay, how many beads are there? 3. Good. Now, how many are missing? This one's tricky because there's a lot of beads missing. You have 3 white, so how many white are missing? 2. Good. And how many red are missing? Yes, all of them. How many is that? 5. Good. So you have 5 red beads missing and 2 white beads missing. How many beads is that altogether? 7. Good job. So what's our number sentence? And they should be starting with the amount that they can see. 3 plus 7 equals 10. Good. I'm going to stop there because this video is very, very long already. But I can show more of those at another time with the whole math rack. But that's it. And then my last video for math will be addition and subtraction.